Hello everyone, we are still continuing with functions and now we're going to have a look at the quadratic function. Before I even go far, please don't forget to like our videos and also subscribe to our channel, and please share this information with your fellow metric friends as well as those who are upgrading. Guys, we have quality learning material here so please take advantage of it and do share. So now, in grade 10, you learned the simplest form, right? And that's basically where you had the function y is equal to ax squared, okay? So what does a here represent, okay? So basically, if a is positive, then you have like a smiley face parabola. Because you can see here, smiley face, and there's a minimum at the bottom. If a is negative, then you have a sad face parabola with your maximum on top. So what do I mean? Okay, so let's say that's your y-axis and that's your x-axis. So a smiley face parabola is like that. Okay, and there's a thing about a as well. It's not only whether it is negative or positive, it's also whether it is bigger than 1 or smaller than 1. Let me just redraw this again. So let's say you have a is equal to positive 1, and there you have your function. Okay, if you're going to have a value bigger than 1, then your parabola tends to be quite narrow. Okay, so let's say you have 2x squared. Okay, whenever you substitute values here in the x, like 1, 2, and 3, you're going to see that by the time you get to 3, okay, 3 squared, that is 9, and 9 times 2, your value here will be 18. Okay, but if you have a fraction, okay, let's say you have a half x squared, your graph will tend to be more flat. So it'll look something like that. And why is that? Again, if I'm using the example of 3, if I have 3x squared, that is, 3 squared, that is 9. And 9 times a half, that's 4.5. So for the same value, maybe at 3, you would have like 4.5 here. Okay, but for the red line, okay, so here, somewhere here, you would have 18. So the bigger your a values are, the narrower your parabolic function will be. But the smaller your a values are, I mean less than 1, then the wider. Okay, it's going to be quite wide as opposed to being narrow. Okay, and the same would happen if you have a sad face parabola. Okay, so if you have a sad face parabola, like I said, you have your maximum value. Okay, so it would be something like this. Okay, I think let me just do it like that. And the same would apply if you have a value bigger than 1, it'll be very narrow, and then if you have a value smaller than 1, it'll be quite wide. Okay, so that's basically that. And now in grade 11, you now have q. Okay, so now we're shifting the graph. It's no longer at the origin as you learned in grade 10. Okay, now we can start moving the graph. So what does q actually tell us? Well, basically, if your q is a positive value, okay, actually wanted to say if it's bigger than 0, then it starts shifting up. Okay, if it's bigger than 0, your graph as it is at the origin, it starts shifting up. Okay, so now we're somewhere there. All right, if your a is negative. All right, and if q is less than 0, well, basically your graph has been shifting down from the origin. Okay, so it's basically a vertical shift. Q indicates a vertical shift. Okay, now we get to the third type. You can either write it like this, okay, where it's ax squared plus bx plus c, but I prefer putting it in this form. So basically, if you take ax squared plus bx plus c and you complete the square, I hope you haven't forgotten how to complete the square. So when you complete the square, you put it in this form over here. And we recognize q we know that that is the vertical shift. And then we have P as a horizontal shift. Okay, so now you have your graph over there. It's no longer at the origin anymore. Okay, it was originally there, maybe if you have a smiley face, but if you shift it, so if you have negative P, it's basically like shifting it to the right, and you have positive P, it's basically shifting it to the left. So yes, let's say we shifted it to the left and we shifted it up. So now your parabola is somewhere there. Okay, that shift there indicating the horizontal shift, which is P, and this shift over here representing the vertical shift, which is Q. Okay, so yeah, now that's where we are in metric. We're dealing with parabolas that have shifted quite a lot. And the other thing, when you have it, the equation in this form, P and Q actually give you the turning points. So if you have a negative over here, you could just indicate that actually your turning point is just P and Q. If you had a positive here, then your turning point would be negative P and Q. All right. Okay, and what I wanted to show you as well is, why do we say that x minus P is actually a shift to the right? And then we have x plus P, which is a shift to the left. Why do I say that? Well, basically, if you were to take x minus P, né, and make it equal to 0, okay, or you have x plus P equal to 0, then you would see that x is actually equal to P, which is positive. And here you would see that x is actually equal to negative P. So if x is equal to negative P, you know that it's shifted to the left, because now we are on the x-axis, it's on the negative side. All right, so it's shifting, yeah, basically to the left. But if x is equal to P, positive P that is, then it is shifting to the right. Okay, so that's basically how we know. And of course, if you wanted to know the turning point, I mean, PQ, is it positive, is it negative? This is what you would use. You'd say whatever is in the x minus P, and you just make it equal to 0. Okay, and whatever you get there, you would know, okay, my turning point then would be P and Q. Okay, so again, with this function, you can calculate the x-intercepts. I've shown you with the straight line graph how you do it. If you want to calculate the x-intercept, and I wrote here if it exists. If you want to calculate the x-intercept, you're basically going to make your y 0. What do I mean by saying if it exists? Okay, let me just erase all of this here. And let me use a different colored pen. So if it exists, you have, maybe let's say you have your parabolic function and it's there at the origin. Okay, so the x-intercept, you're gonna only have one x-intercept. Okay, it's there where it's 0 and 0. So basically, if your turning point touches the x-axis, you're just going to have one x-intercept, which is your turning point. Okay, in the lesson where it talks about the let me just check quickly, the determinant, the discriminant, okay, where you're going to use your quadratic formula. It actually talks about it, where what happens when you have intercepts, roots, no roots, anything like that. So that's why when you have a turning point that is on the x-axis, you only have one intercept. Now let's say we shift the graph a bit lower. Do you see now you have two x-intercepts? Okay, so yeah, in that case, a quadratic function can only have a maximum of 2. Okay, a linear function, only 1. A cubic function, it can have a maximum of 3 x-intercepts. All right, but now, what if we have shifted this parabola of ours to the left and up, and now it's somewhere here? Do you realize that you actually don't have any x-intercept? It is possible, guys, that when you calculate, you actually don't have x-intercepts. Please don't be under the impression that because I have a parabola, I must have two x-intercepts. No, you can have two, you can have one, and sometimes you don't have anything. Okay.
What's up?
So yeah, basically that's the story with the x-intercepts. Now, the y-intercept, you'll definitely have a y-intercept. Okay, it doesn't matter if you shift the graph left, right, whatever, it will have a y-intercept eventually. If you haven't restricted the domain, it will have a y-intercept. And when we calculate the y-intercept, we basically make x equal to 0. Then you talk about the domain. So the domain of a parabola, basically it's the same with the straight line function, was basically x is an element of R. Because if you look at your parabola, you go, I'm just restricted by the page here, but you can see I can actually go on and on and on from negative infinity to positive infinity. It can go on unless if the domain has been restricted, but it can go on. But with the range, remember range, those are the y values, you have to, it depends. If you have a value of a that is positive, then you definitely have a minimum, okay? Your minimum, let's say it's here. So your range in this case, if I'm looking at this one, it would be y is an element of, maybe a square bracket here, 0 to positive infinity. Remember, infinity always has round brackets. It never has a square bracket because we don't know the value of infinity. It's undefined, all right? Again, here you have your minimum, so it depends. Your minimum, as long as you have your turning point, you can take the y-coordinate of your turning point, and that is where your graph starts, provided that you have a minimum. Also, if you have a maximum, where you have a side face parabola, your turning point here will tell you, okay, fine, basically y is an element of, because we start from negative infinity, and we go all the way to the y value of that turning point. Okay, so that is basically the range here. The range, it's not just y is an element of R. Be very careful. There is a limit. It depends. Do you have a sad face, or do you have a happy face parabola or a sad face parabola? And that will indicate the limit. Okay, so now let us look at examples. Let's see if we can determine the turning point of this function. Okay, so there are two ways of doing it. Okay, you have this formula where you can get the x-coordinate of the turning point, and after getting the x-coordinate of the turning point, you can then substitute it in the function, in the equation, and then get the y-coordinate. Another way of getting the turning point, well, you can complete the square. So let's see, did I leave enough space? Okay. Let me try doing both ways, okay, so that I can at least remind you of how to complete the square. All right, so if I were to get the turning point, if I were to get the x value of the turning point, well, that's basically minus b over 2a, okay? This would indicate a. This is a happy face parabola. That would represent b, and that would represent c. That would be a y-intercept. Okay, so I have negative 6 over 2 times 3. So I basically have positive 6 over 6. So the x-coordinate of my turning point is 1. And if I want to know the y-coordinate of my turning point, I basically substitute this y into the formula. So 3 1 squared minus 6 1. So I have 3 minus 6 minus 1. That's the same as 3 minus 7, which is negative 4. So basically, my turning point is 1 and negative 4. This was a nice and easy way of doing it. Now, let us go to completing the square. Okay, so the first rule about completing the square, ladies and gents, is that you have to remove the coefficient of x squared. You need to have a coefficient of 1. Okay, so the first thing I'm going to take out 3. Okay, and what am I left with? I'm left with x squared minus 2x minus 1 over 3. Okay, now I can start completing the square. You can't have any coefficient of x squared other than 1, or else it will not work out. It will be wrong. Okay, so let us start. Let me just use square brackets. So with completing the square, what you do is you take the coefficient of x, okay? So I'm going to say plus, I added, so I'm going to take the coefficient of x, which is minus 2, and I divided by 2, and then I squared. And then the very same thing, I subtracted. So negative 2 over 2, and then I square. And then I have my value of c there, which is a third. Okay? So now let us continue. I have x squared minus 2x, okay? And then minus 2 divided by 2, that's negative 1. Squared, that's just positive 1, okay? And then I have negative 1 there, and I have negative 1 over 3. All right? And then if I am at this point over here, okay, I can then write my equation like this. So I have x, and because I have negative 2 over here, I'm basically going to have a negative 1, because if I say minus 1x, I get negative 2x. And if I say minus 1 times minus 1, I get positive 1. So I can then square it over there. Okay, and then I can rewrite minus 1 as 3 over 3, or negative 3 over 3 minus 1 over 3. Okay, and that will basically be like this. Minus 3 minus 1, that will be minus 4 over 3. Okay, I'm almost done. Now that I've taken out the 3 to complete the square, I need to multiply by 3 again. Okay, so that I can remove the square brackets. So I would have 3x minus 1 squared, and I would have negative 4, because negative 4 over 3 times 3 is just negative 4. And then because of that, I can then get my turning point, okay, from these values over here. So my turning point is minus 1 and, sorry, it's 1. It is 1. Remember, I said x minus 1 equal to 0, so x is equal to 1, right? So my turning point is 1 and minus 4. Okay, so that's basically that. I actually forgot. Yes, but we did. In the previous way, where we got the turning point via minus b over 2a, we did get minus 4. I remember our turning point, that x value was 1, and once we substituted 1 in this equation over here, we got 3 minus 7, so it's minus 4. So that is basically this. And I like the part of completing the square, because I have my turning point, it's right there. But I guess this is time consuming, so whatever works for you, please do that. Okay, now let's look at the second question, where it says state the domain and the range for this function. I'm gonna sketch it quickly for you so that you can see. Okay, or should I? No, I'm not gonna sketch it, because first of all, my domain is not restricted. And if my domain is not restricted, I know the parabola, I know it's a sad face, okay? It looks like this. And I know my turning point is actually 1 and 3. That's all I can sketch for you, okay? So I know that when it comes to the x values, they can go as far to the east and as far to the west, okay? So basically, x is an element of R, okay? Or I can go from negative infinity to positive infinity. But what about the range, okay? Y, remember I told you with the parabola, you can never have x, y is an element of R. Never. So y is an element of negative infinity, because it starts from negative infinity and then it ends at 1. Okay, no, it ends at 3. Sorry. It ends at 3. Okay, cool. Okay, so now we get to the axis of symmetry. Alright, so when you have a parabola, so basically axis of symmetry is what would cut your function in half, okay, such that if you were to paste the two halves together, they would fall, exactly on one another. Okay, so if I were to have a look at my parabola like this, I can't say my axis of symmetry is here. But if you were to draw a line over here that actually passes the turning point, then that would actually cut your parabola in half, okay? Such that if you were to fold it, it would fall exactly on top of each other. Alright, so that is your axis of symmetry. If they were to say, give us the equation of the axis of symmetry. Okay, you have your function over there. You know what your turning point is. Maybe let's say you have your turning point there at 1 and minus 5. And they are saying, okay, what is the equation of your axis of symmetry? That's basically looking at the x value. So you would then say x is equal to 1. Okay, and if you had your equation in this form, okay, where you have x minus p plus q, if you have it in this form and they were to ask, give us the equation of the axis of symmetry, you would then say x minus p is equal to 0, therefore x is equal to p. And that is it. Okay, that is the axis of symmetry. And now we get to sketch the parabolas. How do we actually sketch them? Okay, so I'm going to just take it step by step. So here, let's just look at the first example. All right. Firstly, we're going to determine what is the turning point. Well, fortunately for us, the equation has been written in such a way that we can see what the turning point is. Remember, if you're going to get the x value, it's like saying x plus 1 is equal to 0. So x is negative 1. So our turning point, therefore, is minus 1 and minus 3. Okay, I can see here that I have a negative a value, which is negative a half. So I'm expecting a side face parabola. Okay, so I already know the side face parabola. I know my turning points. My axis of symmetry, well, I know that it is basically x is equal to negative 1. Now let us go to my y-intercept. My y-intercept is basically where x is equal to 0. So I have negative a half, 0 plus 1 squared, minus 3. So basically I have 1 squared, which is just 1. So negative a half minus 3, that's negative 3.5. Okay. So now that you have your y-intercept, you need to put it in coordinates. Okay. Remember, your y-intercept is where x is 0, and then we know that we have negative 3.5. Now the x-intercept, that is where y is 0. So I'm going to have negative a half x plus 1 squared minus 3. I'm going to take 3 to the other side, so it is positive. Okay, I'm going to take negative a half to the other side, so it's going to be negative 6 is equal to x plus 1 squared. Then I'm going to root both sides so that we can get rid of that squared. Okay, we have a problem. You can't have a root negative 6. This is like, you're going to get an error in your calculator for this side. Okay, so once we get here, I know that I actually don't have any roots. Okay, remember when I showed you the different ways where you actually get a point where you don't have any roots? So there aren't any real roots. Okay, so I don't have an x-intercept. Yeah, so therefore, no x-intercepts. Okay, so when you get something like this, don't panic and think you've done something wrong. There isn't an x-intercept, and that's okay. So now, the domain and the range. I think it's actually better sketching it first, and then we're going to determine the domain in the range. So we know our turning point, and we know our y-intercept, and we know our axis of symmetry. Okay, so let's plot it. Then we'll determine the range. And okay, so I know that my axis of symmetry is at -1. Oh guys, so yeah, it's Sunday here in Pretoria. On our way to church, so I decided while they bath, let me just record. So yes, I have my axis of symmetry. And what is my turning point? My turning point is -1 and -3. So I have -1 there, and I have -3. Let's just say -3 is there. So this is my turning point. And then what is my y-intercept? Do you see why we don't have roots? So my y-intercept is 3.5. So, Mommy. Yes, my baby.
Finish my jungle.
Good. Okay, go to daddy. I'm coming now. Alright, so there's our y-intercept, -3.5. And we can see that it won't have any x-intercepts because there's no way it's going to touch it. Okay, so that's basically the plot. So after sketching this graph, we can see that our domain is actually x is an element of R. Okay? Because it goes from -infinity to +infinity. Our range is restricted by the turning point, right? So it actually starts from -infinity because it's a side face parabola, and it ends the y value -3. It ends at the y value -3. So yeah, this was actually quite nice. And let us see the second part. I'm actually gonna write it in a different color, green.
Hello.
Hello, look there. There's the camera. Say hello.
Hello.
Today I'm gonna teach you parabolas. Okay. Alright guys, so we're gonna have a look now at the second function, and we're gonna sketch that. We're gonna plot that. So firstly we need to determine the turning point. And we're gonna do it by using the minus b over 2a to get the x coordinate. Okay. Alrighty, hello, and we are going to continue hours later. Okay, so we're going to have a look at the second function. Okay, so we can see here that it wasn't written in the form where you are completing the square. Okay, so in this case I'm not going to complete the square so that we have in a form like this. I'm just basically going to use that calculation where you get the x coordinate of the turning point. Then once you get that, you substitute it back into the equation to get the y value. All right, so remember the x coordinate of the turning point. Well, that's basically going to be -b over 2a. Okay, and remember this represents a. The coefficient of x squared is a. The coefficient of x, that's b. And then the final part there, the y-intercept, that is 7 over 2, which is like 3.5. Okay, so -b, so basically we're going to have -4 all over 2 times a half. Okay, and our answer will therefore be 4 over 1. So the x value is going to be 4. So we're going to take that x value and then substitute it back into the equation. Alright, so we get y half 4 squared minus 4 times 4 plus, I'm just going to say 3.5. Okay, and if we multiply that out, basically 4 squared is 16 times a half, that will be 8. Okay, then I have 8 minus 16 plus 3.5. Alright guys, so 8 minus 16, that is -8. And -8 plus 3.5, that will be -5.5. Okay, so if I have -8 plus 3.5, I think that's going to be 4.5, not 5.5, right? Yeah, so it has to be -4.5. So this is, this should be a happy face parabola. Okay, so we're going to have a minimum. So I already have, so basically the turning point, the coordinates of the turning point that I have here would be 4 as well as negative 4.5. Okay, yes, it is 4.5. I'm confident. But guys, please, in exams, use the calculator. Because your mind is everywhere, you're going to start thinking of many things. Even if you're adding 1 plus 1, put it in the calculator. I normally think ahead, so I end up making silly mistakes. Alright, so now the axis of symmetry. I did tell you guys that the axis of symmetry, that's basically the x coordinate of your turning point. Okay, so if we had 4, then the axis of symmetry, the equation, it will just be x is equal to 4. Alright, then we go and calculate the y-intercept. Okay, so y-intercept, that's basically where x is equal to 0. So you can see from the equation that the y-intercept is 3.5. But if you can't see that, remember the equation is y is equal to a half x, but we're going to substitute 0 where x is. And then we have minus 4x. Okay, is it plus or minus? Plus 3.5. I'm just going to put there 3.5. And therefore our y-intercept will be 3.5. So if I were to put the coordinate of the y-intercept, because ultimately you need to put in the coordinate, it's going to be 0 and 3.5. Okay, or you could have just written it in fraction form as it was given. And then the x-intercept, well, the x-intercept, that is where y is 0. So we're going to have 0 is equal to a half x squared minus 4x plus, I'm just going to use 7 over 2. Okay, and then I'm going to get rid of the half. Okay, if I get rid of the half, I'm going to have x squared. Okay, and then if I say 4 or negative 4 divided by a half, well, basically that will be negative 8. Okay, because if I take a half times that negative 8, I'm going to get negative 4. And also here, that's just basically going to be 7. All right, cool. So yeah, now we can just factorize. If you are not so good at factorizing like this, you are more than welcome to use the quadratic formula. Okay, but for me, I know that I have 7 and 1 there as my factors, and if I take negative 7 and negative 1, I'm definitely going to get negative 8. And these, yeah, we put it like that. Okay, so in this case, at least we do have x-intercepts, unlike the previous case. All right, so therefore my x-intercepts, okay, let me just start by saying x is equal to 7 or x is equal to 1. All right, and therefore my x-intercepts, okay, yeah, so therefore my x-intercepts, I have 7 and 0, the coordinates of it, and I also have 1 and 0. And now we can definitely plot. Okay, we can definitely plot this graph. All right, so I have 7 and 1 as my x-intercepts. My turning point, do I have a negative? I have 4 and negative 4,5. So I will do it like this. Okay, just put it like that. All right, so this is my y-axis, my x-axis. I have, they've plotted 1, 2, 3, 4, 5, 6, and 7. I'm pushing everything there. So these are my x-intercepts. I have 1 and 7, and then I have my turning point there, which is a minimum because we have a smiley face parabola. Remember that axis of symmetry was actually there at 4. So we know that, yeah, the turning point is somewhere there. And I think it was negative 4.5. Yes, it is. So let's just say 1, 2, 3, 4, 5. So somewhere here. Okay, no, we don't, yeah. So somewhere there at 4.5, we have our turning point. Okay, turning point is 4 and negative 4.5. And then what is a y-intercept? It was 3.5. Okay, so we have 1, 2, 3. So 3.5 is somewhere there. Okay, so there we have negative 3.5. Okay, because sometimes they would say indicate the coordinates on the sketch. I don't think I did this previously. So if you have all those points, no, something doesn't make sense. Was it positive 3.5? Oh my goodness, I'm thinking this parabola doesn't make sense. Okay, 1, 2, 3, 4, 4.5, 5. Okay, so let's just say 1, 2, 3. So there's 3.5. Okay, now I see my error. All right, so now if I were to plot it, it would look something like this over here. Okay, not the best plot. Okay, so it's gonna maybe do something like, still not the best, but it is what it is. I know you're gonna sketch way better than me. And then we can talk about the range and the domain. Okay, the domain for a parabola, guys, unless if they restricted it, it will always be x is an element of real numbers. Okay, that would be the domain. The range, however, you know that it is limited by the turning point, right? So the range basically goes from negative 4.5 all the way to positive infinity. Okay, so I hope you guys understood how to sketch the parabolas. And yeah, it shouldn't really be like a difficult process, really. Yeah, as long as you can get all of these, the turning point, the axis of symmetry, y-intercept, x-intercept. If you remember how to do completing the square, then you're good to go. You definitely got this. Okay, now what if they happen to give you intercepts or points or whatever, and they say from all of this find the equation of a parabola. Okay, so for example here we're going to start with this one, where all the intercepts are given. The x-intercepts are given, the y-intercept is given, and they're like, yeah, get the equation of this parabola. They like questions like that. Even with cubic functions, they would give you some points and then they're like, tell us what is the equation of this cubic function. Okay, so this is what we're going to have a look at next. Okay, so basically we are going to use this equation over here. So if you are given intercepts, that is the equation to use. Okay, and we're going to start first by substituting the x-intercepts. Okay, and then we're going to then plot, or rather not plot, but substitute the y-intercept. Or we can do it, no, let's just start first with the x-intercepts, then you're going to introduce the y-intercept, and then we're going to get the value of a. Okay, yeah, so basically we're going to say y is equal to a, okay, and then x minus, so the first intercept, so that's basically going to be minus 1 over there, so minus and minus, that's going to be a plus, and then we're going to have x minus 4. Okay, then I'm just going to multiply that out, all right, and then multiply the a in. So I'm going to have x squared, okay, plus 1x minus 4x. I will then get negative 3x, okay, and then minus 4. All right, then I'm just going to multiply in the a. Okay, minus 3ax, and then minus 4a. All right, then I'm going to substitute in the y-intercept. Okay, so obviously the y-intercept means that x is 0. So y will be 2. And everywhere where I have x, I'm going to have 0 now. Okay, minus 3a, 0, minus 4a. So basically at the end, I just have negative 4a is equal to 2. All right, so now we're going to solve for a. Okay, and then a will be 2 divided by negative 4, which is just going to be negative a half, okay? And that does make sense, that is negative a half, or rather that it's a negative value because you have a sad face parabola, okay? So now that we have a, remember that we have this equation over here. So all we have to do is substitute the value of a, and then we're going to get the equation of this parabola, all right? So then y is equal to negative a half x squared minus 3 times negative a half x minus 4 times negative a half. And our final answer then will be negative half x squared. Okay, then we're going to have positive 3 over 2, which is just 1,5 x. And then we're going to have positive 2 because it's just negative 4 times negative a half. Okay, and yes, we can see, remember 2, that would represent your y-intercept, and we know it was given that the y-intercept is 2, so we should get that. And that is, yeah, that is the equation. Remember the equation of a parabola, if you haven't written it in the form where you've completed the square, it's just basically ax squared plus bx plus c. So you can write it in this form, okay? If you really wanted to go further and put it in that form where you complete the square, please, that's really up to you. But I'm just going to leave it here. I've already shown you how to complete the square. All right. Now what do you do when the x-intercepts are given and another point? Okay, so you're still going to use the same equation. All right. So similar to how we did it previously, we're going to do it the same way again. You're first going to determine what a is and then substitute it back into the equation. Okay, so we're going to just focus first on the x-intercepts. All right, so x minus 1 times x minus 5. All right, and I'm going to just multiply that out. So I'm going to have x squared, then I have minus x minus 5x, so that will give me minus 6x, and then I have a positive 5 over there. Okay, if I then multiply a throughout, this is what I get. And now what I can do is substitute in the point that was given. So the point that was given there is minus 1 and 12. So in the place of y, I'm going to put 12. All right, and in the place of x, I'm just going to put there minus 1. So I have a minus 1 squared minus 6a minus 1 plus 5a, and then I'm just going to multiply everything out and then solve for a. So I have 12 is equal to a plus 6a plus 5a. So now I have 12a. 12a is equal to 12, therefore a is equal to 1. Okay, this is a nice and easy one. So when I get the final equation, I will then say y is equal to, remember I'm going to substitute it in this one here, because now I have the value of a. I can then get the equation of the parabola. So I have, by the way, the pronunciation, some people say parabola. I've been saying parabola, so I don't know, guys, it's really up to you. I don't think it should matter much as long as you know what you're doing. So whether you say parabola or parabola, or you just want to stick to quadratic function, that's all cool. All right, and yes, we have a positive a value because we have a smiley face parabola, right? And if you wanted to know what your y-intercept was going to be, well, basically we just saw it from the equation. It would just be, the coordinate would be 0 and 5. Alrighty. Oh, I left a lot of space. Lastly, what if they gave you a turning point, okay, and another point is given? So basically for that, we will be using this equation, okay, the simplified. And you know that P and Q are actually coordinates or values of your turning point. So what I would suggest is you first put that in, and then you can substitute the point later. All right, so we have y is equal to a, and I have x plus p. I actually like using, it's really up to you, but I like using the form x minus p. Okay, not x plus p. The one that's actually given in the formula sheet is x minus p. All right, so x minus p. So what we have here, x minus p is equal to minus 3. Okay, so if you wanted to know, okay, now what am I saying here? X minus p is equal to 0. Yeah, right. Let me not complicate matters for myself. Yeah, so basically here we have negative 3, right? And if we have negative 3, so it means that I actually have x plus 3. Okay, because if I have x plus 3 is equal to 0, then my x value will be negative 3. That's what I wanted to do. I don't know why I complicated my life there for a moment, but we're back now. So yes, it's going to be x plus 3, okay? And you don't even have to calculate this. Just by virtue of having x minus, and in the place of p, you just put in the negative 3 as you have it, okay? So you can do exactly that, and not what I was doing earlier on. And you square it, okay? And then q, well, basically that's just going to be 1 because it has shifted 1 unit up, okay? It shifted 3 units to the left, right? If it was originally here, if it was originally at the origin, okay, so clearly it's not easy. It moved 3 units to the left and 1 unit up, okay? So we're just going to say plus 1. And then I'm going to multiply it out. Okay. So I'm going to have x squared plus 6x plus 9 plus 1. And then I'm going to multiply in the a. So I have a x squared plus 6ax plus 9a plus 1, and then I'm going to substitute in the point that was given. We were given a point of 1 and 5. So in the place of y, I'm going to put there 5, and in the place of x, I'm going to put 1, so that we can get the value of a. Okay, we have 9a and then plus 1. Alrighty, so we have 5, we have a plus 6a plus 9a plus 1. All right, so a plus 6, 1 plus 6, that will be 7a, and 7a plus 9a, that will be 16a. I'm just going to put it this side, 16a, and then if I take 1 to the other side, I'm going to get 5 minus 1, which is 4. Okay, so if I were to then divide by 16, I'm basically going to get a quarter. So a is a quarter, and if I if I put it in the equation, well, I'm going to write it this side. So basically y is equal to a quarter x plus 3 squared plus 1, and that would be my equation. All right, goody. So yeah, and then what I wanted to talk about next is basically the average gradient. Okay, so because a parabola is like a curve, with the straight line, getting the gradient is like easy. You just get 2 points on a straight line and you calculate the gradient, which is the change in y over the change in x. But in a case where you have a curve, like a parabola, do you realize if you were to put a point there, and let's say you had a tangent line to the curve, it's something like this, and you put a point there and you had a tangent line. Basically, that tangent line, where that point is, that the point would actually give you the gradient of the tangent line. Okay, but now, if we were given 2 points on the parabola and they asked us to get the gradient, what we would be doing is actually calculating the average gradient. Okay, because if you go across, if you just put points here, and you're calculating the gradient, you would have this line here, that line, like it would just be many lines. Okay, so ultimately what we want to do is calculate the average gradient, and to calculate the average gradient you just need 2 points. Okay, and you would definitely use the equation for calculating the gradient, so you just say m average. Okay, and again, change in y over change in x. So whenever you see average gradient, please don't panic. They say average because you're dealing with a curve, okay, and there are different gradients throughout, but you at the end you just want the average gradient. So you just take 2 points on your curved function, like a parabola in this case, and you calculate the average gradient, which is delta y over delta x. So that's what I wanted to say there with the average gradient. I'm not going to calculate it. You can do it in your own time. And yeah, that basically cuts it then for the parabolic function or the quadratic function. Guys, it can get a bit tricky, yes, when during an exam they put all the functions together. Literally you have a parabolic function, a linear function, and they just add in there a hyperbolic function, which we're going to talk about later, and then finally an exponential function. They can put everything together, but you shouldn't panic, especially when you have two graphs in the same set of axes. It's not a time to panic. You can work it out. As long as you know the basics, you're good to go. So let us now do the hyperbolic function.